plug this in so you can see. Right, so the next one's a little bit tricky there. You're given there's two missing numbers. No, one missing number. Is that you? No, I know it wouldn't be you, Amjad. Okay. Right. Can you see? Or can you see? Not yet. Oh, come on. What's wrong with this thing? Oh, come on. I got the wrong cable in. Young Kang, is there another cable loose? Is there another cable anywhere?
So, would the standard deviation be 9.6?
Oh, no, it's working. No, that's the computer.
So is it the first and last box, or just the first box? Because the last box is
There we go.
At 50.
Just a sec, sorry. Now, what were you saying, Mo?
For the question before, the last box ends at 50, so shouldn't you use 50?
No, because if you had something like 50.01, it could go in. You would end at 50 if you knew that 50 was the maximum. So, like for example, if you were measuring sugar in something which had a weight of 50 grams, then the most sugar you could have in it is 50 grams. But you have no reason to think that 50 is the end of the story.
So it's depending on the problem.
Yeah, here it's quite clear that 0 has to be the start. Yeah. Okay, so the next one here. You have these numbers, 5, 4, 2, x, and 9. Okay. Now, I actually give you more information than you need. I said that the mean is 5.2 and the standard deviation is 2.59. I didn't need to give you both pieces of information. So, which one would be easier to use? The fact that the mean is 5.2. Yeah. So what's that saying is 5 plus 4 plus 2 plus x plus 9 over 5. That should equal 5.2. Yeah. So what's that? 5, 6, 7, 8, 9, 10, 11, 20 plus x equals 26. 5 times 5.2 is 26. Is x equal to 6? I never actually have the answer for 11 at the back. Okay, now 10 is harder because now there's two numbers missing. Can I scroll down? Yep. Okay.
Could we name it x and y?
Yeah, we'll name them x and y in number 10. So we'll have 4, 10, 4, x, y. Now I tell you the mean is 6.4. So that means 4 plus 10 plus 4 plus x plus y over 5 equals 6.4. Yeah? Which is 32 if you multiply by 5. 18 plus x plus y equals 32. Is that right? So x plus y equals 14. 32 minus 18 is 14, yeah? Yes?
Yes.
Are you sure?
Yes.
Okay. Right, that's our first equation. Now the second one is much harder. We know that the standard deviation is 2.88. So that means here 2.88 squared equals 16 plus 100 plus 16 plus x squared plus y squared over 5 minus, and then I'm using this formula.
Why is it y5?
Oh, sorry, I said squared, but I wrote 5 because I was thinking of the next step already. Y squared minus 6.4 squared. Yeah. So if you could type in 2.88 squared plus 6.4 squared and multiply that by 5, that should equal 132 plus x squared plus y squared. So that means x squared plus y squared is equal to that answer you get minus 132, please. After you minus the 132, 100 and 0.272. Yeah. Okay. Right, we've seen these types of problems before in algebra. What would be the best thing to do here? Substitute, very good. So we could say, we'll just say y equals 14 minus x and put that in, yeah? So now you get x squared plus y squared, which is, what's 14 squared, Mo? Please, 14 squared. 196. So it's x squared plus 196 minus 28x plus x squared equals 114.272. So that's 2x squared minus 28x, and then 196 minus 114.272. 196 minus 114.272, please. 81.728 equals 0. So that's x squared. Well, there's no need to simplify because we're just going to use the formula anyways. We'll get two answers for x. So x equals something or something else, and then we can sub it into this guy to get the y. So if you have your calculator, you can do mode 52 if you have the Casio.
175.
What's the first answer?
175 plus 3.
Give it to me as a decimal.
9.85.
9.85 or
4.15.
4.15. And if you sub 9.85 into this, you'll get 4.15. And if you sub 4.15 into this, you'll get 9.85. So the answer is either 9.85 and 4.15, or 4.15 and 9.85. But you actually, yeah, you don't care about the order because it's data. So the answer is 4.15 and 9.85 is missing. For some reason I have 5 and 9. I think I said why are the missing integers, but yeah, forget about that. This is better. Can you hand me a spare pen, please? Uh-oh. Quickly. Bum, bum, bum. Okay, I got it. Exciting. Right. Okay, the last one there, I have to switch it back to Excel. When you're ready, I'll switch it back to Excel for the last one. switch it? Do you have this one? Yeah? Okay.
But if it was integers also, would it be
Ah, no, delete that. I don't know why on earth I said that.
or in
Yeah, no, just forget about that. Screw that. Okay. Right. Number 11, last one now. Okay. 98.33. Right, what's next?
98.06.
98.06.
101.5.
101.5.
99.58.
Okay.
100.92.
100.92.
99.77. 99.25. 98.95. 98.29. 100.85. 84. 99.88. 101.07. 100.75. 99.71. 101.72. 98.95. 99.3. 100.01. 100.53. 98.17. 101.01.
101.01.
99.11. 101.68. 100.75.
100.75.
100.04.
That's not. Right. What is the mean height of these trees? So if you add them all up and divide by how many you have. Actually, let's see how many you have. Do I tell you how many we have in the question? No. You have 25 trees. And the mean? Add them all up and divide by 25. You get 99.9268. And then the standard deviation. You get 1.099 is the standard deviation here.
So they won't put choice like this in the example, right? No.
No way. Right, the next one is interesting. How many tomato plants are within one standard deviation? So, guys listening? For what I mean for that one is, take for example, let's take a one like 100.75. How far away is that from the average? Well, that would equal this number minus this number here, yeah? So that's 0.8232 away from the average. How big is the standard deviation? 1.099. So is this more or less than a standard deviation away? Less. Okay. So this one is less as well. This one is more. So to make it a little bit easier to see, what I'll do is I'll divide this number by the standard deviation. So if I get my answer is 1, then it means it's 1 standard deviation away. If I get less than 1, it means it's less than 1 away, and more than 1, it means more than 1 away. So it's easier to read. So this one is 1/10 of a standard deviation away. This one is 3/4 of a standard deviation away. This one is about 1.5 standard deviations away. So you just run through all of these. Now, which ones do we care about? Or the negatives, because I didn't say which way. It could be more or less. So I'll just get rid of the signs, because I don't care about that. And copy that down. Okay, so let's see. I'll just put it over here. is this more than 1 away? So the answer is, if this number, flip's sake, if this number is more than 1, the answer is yes, otherwise it's a no. So that's yes. How many yeses have I got here? Right. So let's just count up all the yeses here. Right, so 8 of my data points are more than a standard are within 1 standard deviation away. And I ask you, what's that as a percentage? So let me just change this into percent. So that's 8 divided by 25 times 100. So 32% is within 1. And then I repeat again for within 2. So the only difference is I'm looking for when these guys are more than 2.
Sorry, so you divided by what? 8 divided by
25.
25.
Yeah.
It's less than.
Yeah, and it's not E, it's still D. Leave the little fly alone. Now, do you notice here that none of, actually you can see it here, none of these numbers are more than 2 standard deviations from the center. So the standard deviation is about 1.09, so let's just say that's about 1. Is any of my data points more than 2 away from the average? No, well the average is 99.92, so if I add 2 onto that, what do I get? 101.92, and you can see from looking at that, none of those numbers are that big. The biggest one is actually like this one. And likewise, are any of them smaller than 97.92? Roughly. No. In fact, what is the smallest? It's like 98, is it? So the answer is 100%. All of them are within 2 standard deviations. But you should remember, I told you this last week. Do you remember I said that if you want, a rough rule is that your biggest number and your smallest number in your data would be 2 standard deviations away from the center. Like that's, I said, as a rough rule here. In other words, all the data is 2 standard deviations either side. Okay. So if I said to you, I have a group of people, their height is 150 centimeters, and the standard deviation is 10 centimeters, then that means I pretty much know everyone is between 130 and 170, because that's plus or minus 20 centimeters, which is 2 standard deviations, yeah? You know, if I said on average people's, let me just draw that for you. If I said the average height is 150 centimeters and the standard deviation is 10 centimeters. Oh, sorry, because it's still on the spreadsheet. Can you see? No? If I said the average height is 150 and the standard deviation is 10, I'm pretty much guaranteed that everybody in the group will be between 150 plus or minus 20. And so in other words, 2 standard deviations kind of represents the ends of the data. And if it falls outside of this, then we'd call that, does anyone remember the word? Outlier then. Yeah. If it falls very much outside of this, you know, so like if somebody comes along with a height of 200 centimeters, then that would be an outlier. How many standard deviations away from the center is this person? 5. 5. Because the center is 150 and they're 200, so there are 5 of these away. Yeah. They kind of like to ask that in the exam. You know, a typical question might be for like 1 mark. You know, they might say at the end of the section B question, something like, you have a number like 175 centimeters. How many standard deviations away from the center is this, from the mean is this? So in this example, what would it be? 2.5, yeah. So like that's what I mean. This is like a 1-2 mark question. Yeah. Okay, I think it was good that we went through all of these. I think it's good. So I'll tell you what. Just take a little break for a couple of minutes and then we'll start the next lesson, okay? So I'm not going to do... Actually, maybe I will have the tutorial still later in the week. Yeah, no, I think I still will. Tutorial's on Thursday, isn't it? Yeah, okay, fine. Alright, just take a break for a couple of minutes and then we'll start the next lesson.